Today we will discuss about the speed of a traveling wave on a string. As shown in the figure, when a wave travels along a string, the particles of the string remain at their respective positions, oscillating in a periodic motion up and down, but the wave travels along the medium. Let at t is equal to 0, the shape of the waveform be shown by the solid line, and at a later time t plus delta t, the shape of the traveling wave is shifted towards the x side as this wave is traveling in the positive x direction. So the value of x changes with time, so the velocity in x direction is equal to change in x divided by change in t. If delta t approaches 0, the velocity should be equal to dx divided by dt. So the velocity of the traveling wave is rate of change of x variable with respect to the time. We know that the displacement yx comma t is equal to r sine of omega t minus kx. We know that the points on the string remain at their respective positions, but the wave travels along the medium. But the points on the wave do not change their positions. That is, here the point A is on the top of the wave, here point A dash is on the top of the wave, but that wave has shifted in the x direction. So A and A dash are at their respective positions. That means the phase of the wave is constant. Phi is constant. Now phi is equal to omega t minus kx. This is only possible if when t increases, x should also increase to keep the phi constant. That means d phi by dt is equal to d by dt of omega t minus kx should be equal to 0. As the phase doesn't change, that is, the rate of change of phase with respect to time should be equal to 0. It is simple differentiation. Now differentiating this, we get d by dt of omega t, that is equal to omega minus k dx divided by dt is equal to 0. Simple differentiation. Differentiation of omega t with respect to time gives us omega. Differentiation of kx with respect to time gives us k dx by dt. As already shown, dx by dt is the velocity of the traveling wave. So omega minus k into v is equal to 0. That means kv is equal to omega. So velocity is equal to omega divided by k. We also know that omega is equal to 2 pi nu and k is the propagation constant, that is equal to 2 pi divided by lambda. Putting the values in this equation, v comes out to be 2 pi nu divided by 2 pi by lambda. 2 pi goes, lambda comes up, that means v is equal to nu into lambda. So the velocity of the traveling wave is the product of the frequency and the wavelength. But it should be borne in mind that the velocity of a progressive wave in a medium depends upon the properties of the medium, that is its elasticity and density. Thank you.